Hello, ladies and gentlemen. This is Mr. Santoro with the next installment of Math 12R screencast lessons.
Anti-differentiation or integration.
Well, I'm recording it. I'm not sure when you guys are going to watch it, but I'm recording it in the evening. This lesson is regarding the motion of a free-flowing object. So we spent a couple of days looking at particle motion problems.
The reverse of
so this is these are problems. Motion of an object in two dimensions. For instance, a ball being dropped from a height or thrown up in the air can be modeled by an equation that gives the position of the object as a function of time, which is pretty much what we've been looking at, S of t. So there's a general equation that describes this kind of
formula here and all that. So
it's S of t equals 1/2 a t squared plus v sub 0, which is your initial velocity, plus s sub 0, which is your initial height.
So if we look at this
velocity as a function of time
2x
is
just 2x
at plus initial velocity
here is a 1 we don't write.
And acceleration
so it's 2x
with regard to time is just equal to a.
So we take the exponent.
So there's a couple of things you have to keep in mind.
Which is 1, and we add 1.
If the height is in feet and time is in seconds,
we will now have an
then
exponent.
a is equal to negative 32 feet per second.
Then whatever
squared.
your new exponent is, you divide.
If the height is given in meters and time is in
the
seconds,
exponent here is 1.
Then a is equal to negative 9.8 meters per second squared.
And when we're done, it looks like this.
Now this is something that I know that they look at on a regular basis.
That's how I got that too.
When they're doing these type of
Whatever
problems
this new exponent is, you divide by
physics.
You divide by that.
So the physics students tell me that I've rounded the 9.8 meters per second squared and maybe even the 32 feet per second squared. But for our purposes, I don't need to carry it to any more decimal places than that.
7, 3, 5.
So suppose the ball is dropped from a window 20 feet above the ground.
We don't know what that is yet.
You have to build the equations in this step, the S of t and the V of t.
Maybe after Christmas.
Okay. In these problems, you have to build your own equation.
Not knowing
so let's take a look at this.
So
the ball is dropped from a window 20 feet above the ground. So that's your initial height, your S sub 0, which is the last term in the equation.
Was f of x equals x squared.
So if we build this equation,
unknown c.
S sub 0 is 20.
The suspense of
and since it's feet, we're going with the negative 32 feet per second.
I know the suspense is going to kill some
so you just put that into the equation. S of t equals 1/2 times negative 32
constantly
t
thinking,
squared,
what is c? What's the value
plus
of
0 t, because the initial velocity was 0.
Let's go through it again.
Plus 20, which is your initial height.
Your derivative.
And on the right side, I'm looking at building the v of t function, which is just negative 32t, because your initial velocity,
the 1, you add 1,
v of v sub 0, your initial velocity is 0.
Divide everything, or divide that expression.
So if we continue on the left side,
so
S of t is equal to negative 16 t squared.
The examples are on the back.
Plus 20.
So if we look at the first
your
one,
a of t on the right side, which is this up here, is just negative 32.
When you look at this, the exponent here is
so there's
1.
There are your functions.
So
you have S of t, v of t, and a of t.
Our new expression will be
the problem we
3x
were looking
squared.
at the last couple of days. I gave you the S
divide by 2. Because our
now
new
you've got to
up
take
here is
the
2
components from the problem and build that function.
And so when we clean that up,
and then v of t is your first derivative, and a of t.
Don't forget to add the plus c at the end. That's important.
So now that we've built the function, let's now answer
take a
some
look at the
questions.
next one. Our exponent
Find the height of the ball after 1 second.
Going to
well, height is location, so we're going back to our original function.
And then divide by 2. So we have x squared over 2.
And we'll evaluate for s of 1.
Typically, we would write that 1/2 x squared.
So negative 16.
Okay. Try not to leave it.
Which is 1/2 times negative 32.
Form. Make the fraction the coefficient.
Okay. That's what that came from.
Over 2, make it 1/2 x squared.
Times 1 plus 20. So negative 16 plus 20. So after 1 second, the ball is.
We have an exponent of
4
2
feet high.
for x squared. So the exponent of 2 becomes a 3.
Now let's find the velocity of the ball after 1 second. The velocity is your v of t function up here. So we'll evaluate v of 1.
And
so the velocity is negative 32 feet per second.
Okay. Hopefully right now everybody's.
The next one is a two-part question. First part is when will the ball hit the ground?
I'll tell you what, why don't you guys.
And what will its speed be at that moment that it hits the ground?
look at what we've been doing with the exponent, adding 1, dividing by the new exponent.
When will the ball hit the
Or
ground?
the
That means
spin
the
test.
S of t is 0,
And
so
try
the
that
height
one
is 0.
and come back.
So you take the S of t function and you set it equal to 0. And you get 0 equals
Hopefully
negative
everybody
16 t
can
squared
try
plus
that one on
20.
their own. So let's take a look. The exponent of 3 becomes a 4.
You add
Dividing
16
by
t
4.
squared to both sides.
When we clean this
You
up,
have
4 over
16 t
4
squared
is
equals
1.
20.
So the original function,
You divide both
x
sides
to
by
the 4
16. So t
plus
squared is 16 over 20 or 5 over 4. Then you take the square root of both sides.
Let
T
me
is
stop
equal
here.
to the square root of 5 over
We
4,
look at this.
or the square root of 5
These
over
are all
the square root of
self-checking.
4, or the square root of 5
We
over
take
2
what we have on the
seconds.
screen here, x to the 4. And we take
So
the
the ball will
derivative
hit the
of that,
ground in radical 5 over 2 seconds.
multiply 4
Its speed at
times
that
the
moment,
coefficient of 1.
we
You
now
get
go to the
4
v
out,
of t function,
and you take
and
2
since
over
we
4,
know
subtract 1,
time
and you
is
get
radical
3,
5
which
over
is
2,
4x cubed.
you
once
evaluate
you
that
find the
function
original
for radical 5 over 2.
You can
So,
check to make sure you
On the right side, I put the radical 5 over 2
the
with the t
derivative
up here.
of what we just found right here.
Then you multiply by
derivative should
negative
be
32, you get
probably
negative 32 radical 5 over 2,
So let's do one more.
which is negative 16
And this one has
radical
two terms,
5 feet per second.
But you handle each
Now,
term
in some
separately.
problems,
So if we look at this, it's
even though
5x to
negative
the
16
4.
radical 5 is an exact
Now
value,
what
you
we
may be
know
asked
we're going
to
to do is change the
put that
exponent of 4
into
to a 5,
a rounded form.
dividing by 5.
So if we were to round it to nearest tenth
and then the next one,
of
the
nearest
exponent
tenth,
of 2 becomes a 3.
it would be negative
And you divide
35.8 feet per second.
So
That's
the
the
first
velocity
pass
of the
is like
speed the moment the ball hits the ground.
Exponent of 4 becomes 5.
So there are a lot of things going on in the
Exponent
screencast.
of 2, add
So if we
divide
recap
by
a little
3.
bit,
And then when we clean
the
this
motion of an object in 2
our
dimensions
original
being
function
dropped from a height,
is x to the 5th
or
plus
thrown
x
up in the
cubed
air.
plus c.
So you've got the
some unknown
S
c.
of t function,
And like I said, we'll get
the
to
v of t, and the a of
determining
t.
the value of c.
Now,
I'm guessing we
in
won't get to that for Christmas vacation.
the S of t function
So
here,
you'll have to remain in suspense about
t is
c
time,
until
a is acceleration,
after New Year's.
v sub 0
So
is your
thank
initial
you for tuning
velocity.
in to the
In
latest
many
edition
cases, that
of
would be 0,
Math 12-hour screencast.
but you have to read
This
the
is the
problem.
first lesson
And the
in
initial
unit
height
on
is S sub 0. That's the
integration
last
or
term.
antiderivative. So I'll see
So if we
everyone
look
in
at the
class.
example I gave you,
Thank you for tuning in.
the initial height is 20 feet, which is here. And if it's dropped, that means its initial velocity was 0 because somebody was holding the ball. Okay. So we talked about some of these things in class the last couple of days. What's the initial velocity if I have something and I drop it? So just keep in mind all the things that we've been speaking about in class. And go back and replay the screencast if you need to. We'll be doing practice problems in class. And there will be a quiz on the screencast. So thank you for tuning in to Math 12-hour screencast lessons.